Okay, well, let's go ahead and go over this whole naming convention. That's the focus of this lecture. We started on Monday talking about the molecular compounds, which are covalently bound. And those would be covalent bonds. And they are non-metal to non-metal. So basically in the periodic table, we're talking about these guys over here. Now, when you name it, ever since Monday, with all that wind, I think it stirred up a ton of dust. I've been having allergy issues. So whenever we talk about molecular compounds with covalent bonds, we have to talk about the numbers. And that's where the mono, di, tri comes in. The molecular compounds are always made up of two parts, plus a number. For example, if we had OCl2, that would be oxygen, chloride, and this is always a ide, and you can find those in the periodic table or the common ion chart I gave you. There's not very many of them because there aren't very many non-metals. And then we need a number, and this comes from the periodic table directly. So whatever the name is on the periodic table, that's what we're going to put there. Okay, and then we have to talk about numbers. Okay, well, this is 1, so that's going to be mono. And when mono is in the first part, it's optional. So we could say mono oxygen dichloride or just oxygen dichloride. Both are fine. Excuse me again. A lot of my, gosh, I haven't coughed all day, so I started talking. A lot of my students like to put the mono in, even though it's optional, so it's totally consistent. The mono, so this is optional. And this is not optional, which to me is strange. But that's the way it is. So the mono in the second constituent atom is not optional. Mono with the first one is. So that's why mono oxygen dichloride is fine, as well as oxygen dichloride. Okay, and also we talked about whenever we have a molecule made up of identical atoms, similar to these 7 here, those are called diatomic molecules. And there are 7, and you need to know these for Chem 400. But basically, they're the halogens plus these 3. So they aren't too bad to memorize. Sometimes they're called hydrogen, sometimes they're called hydrogen gas. I like to refer to them as hydrogen gas, so you know that, excuse me, so you know that they are the diatomic molecule versions. Okay. All right. Now, today I want to talk about in detail the other major class of binary compounds. Binary meaning 2. Okay, those are ionically bonded. which means that there is a metal and a non-metal bonded together. And because it's a metal and a non-metal, there is a electron transfer of 1 through, well, typically 1 to 2, but more. Not nearly as often. So you can get up to 3, rarely 4 or 5, but frequently 1 and 2. Okay, and that means you have an anion and a cation. Cation is always first, anion is always second. Now, for an ionically bonded compound, no exceptions, you have to have this. If it's something other than that, it's not an ionic bond. It can be a covalent bond, it could be a lot of other things. Okay. Now, because of what we talked about last week in terms of electronic configurations, the groups tend to give up or receive, donate or receive electrons. That's to form a full shell. So these trends here are to form the full shell stability. So these guys are going to lose 1, lose 2, lose 3, gain 3, gain 2, gain 1. And then this is 0, and that is 0. Now, the reason why the carbon group there does not, and this is carbon, doesn't usually, and again, it's doesn't usually gain or lose electrons, is because you're talking about 4 electrons, either gaining or losing, and that's too many. So basically it does nothing and forms covalent bonds, which is sharing electrons rather than transferring electrons. Okay, so when we were naming covalent compounds or molecular compounds, we always had a prefix here that says number. And the reason why we had to have a prefix is because there was no way to tell how many of each one we have. Ionic compounds, however, are charged. Because they're charged, we have to balance them out in number so that their ionic charges net as 0. So the cation charge is equal but opposite of the anion charge. So if we have a +3 here, we have to have a -3 there. Now that's collective of all of the cations and all of the anions. Collectively, we have a net charge of 0. And again, there are no exceptions here. Okay. Now these ionic names come from Now, I've provided you with a chart of common ions, and the names of these ions come from over the many millennia, the alchemists, the Greeks, the Latins have put names to these ions. And some of them are old world names and some are analytical names. Let me show you what I'm talking about here. So if we were to talk about, for example, let's look at the copper ions here. Okay? It says right here that copper can either be a +1 or +2 charge, or +3 or +4, but the most common ones are +1 and +2. The +1 is called copper 1 or cuprous. Both are correct. Copper 2, cupric. Now, this Roman numeral refers to the charge on cation. So copper 2 is going to have a +2, iron 2 is going to be +2, iron 3 is going to be +3. You cannot tell the charge from these names. That's a big disadvantage when using the old world names. Now, the old world names are used by the food industry, the agricultural industry, the analytical physics and chemistry communities use the copper 1s, the copper 2s, etc. Because this gives you exactly the information you need to know the charge on that cation. Where this doesn't tell you the charge. It just says cuprous has less charge than cupric. Ferrous has less charge than ferric, but you don't know how much difference there is. It could be 1 or 2 or 3, you just don't know. And sometimes there is no common name for the cation. For example, titanium 2 and titanium 4, there is no common name. Vanadium 2, 3, 4, 5, there is no common name. So again, the cations can be, not totally, but can be, have 2 different names. Okay, so how do we name ionic compounds? Okay, so let's take some super easy ones. Okay, first of all, is that a correctly written formula for sodium chloride? Well, what is the charge on sodium? 1, that's a group 1 element, so we know that's a +1. And chloride, we know, is a halogen, which is a -1. So I'm going to move this chart up here. So is this balanced? We have a +1, -1. That's 0. So that formula is correctly written. That formula is also correctly written because this says it's +2, -2. So that's probably the most extreme example of simplicity of an ionic compound. So bottom line is you need to go from the name to the formula, formula to name, go back and forth. Okay, so let's look at another one. Let's look at barium. And sulfate. Barium is a group 2. it's a +2. Sulfate is a -2. So the formula is pluses, +2 and -2 equal out. So that's barium sulfate. What if we have sodium sulfate? Well, sodium is Na. You just look that up. Those +1. Yes. Did someone have a question?
No, I put my hand up as a number 1, as in it's got a +1. That wasn't a hand raise, sorry.
Oh, okay, okay. Yeah, you can, by the way, you can write that as plus or +1 too, equally. Frequently, you just see it as a plus, but you can write it as +1 as well. Some people like to be very, very consistent and write the +1 just to make sure that everyone knows it's a +1 and you just didn't forget the number.
I write it as +1, so it's kind of helpful for me.
Yeah, good, 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 good. As long as I want it to be consistent for you. Okay, so is this balanced? Is this balanced? No, we have a +1 and -2. So to get this balance, we need 2 pluses. That means the formula is going to be that's going to be the formula for sodium sulfate.
I'm sorry, can I ask a quick question?
Of course.
Are you gonna post this recording?
Yes. You mean this, what I'm doing now?
Yeah,
Yes.
okay, sounds good, thank you.
Yep. Did you notice there was an absence of the one yesterday or the one on Wednesday?
I'm not sure, actually. I've been a little bit behind on the material. I'll be catching up today, so I just wanted to make sure that I'll have everything for me to review and whatnot.
Yeah, yeah. It'll be and then the old play, you know, under modules, and there will be a video, plus there will be a note sheet that I'll do. And also, a couple days ago, I put the unannotated notes up there as well. So you have it with notes, without notes. Okay, so let's continue on with this naming, because this gets interesting. What if we did something like this instead? How about aluminum sulfate? Well, we already looked up sulfate. We know that's a -2. What about aluminum? Well, let's go over here. Aluminum is a +3. And that does not balance. Okay, so we have this 2 and the 3. Whenever you have a 2 and a 3, I want you to think of the number 6, which is a common denominator between 3 and 2, just like we were adding fractions. We're adding fractions 1/2 plus 1/3. We need to convert that to common denominator 3/6 and 2/6 before we can add them. Same here. So 6 is the common denominator between 2 and 3. So you ask yourself, how many 3s are in 6? That's 2. That makes that +6. How many 2s are in 6? That's 3. Makes that -6. And notice I put the SO4 in parentheses because it's the whole SO4 that's got a charge of -2. So we have to include the whole thing in bracket or in parentheses and multiply the whole thing by 3 to get it up to -6. So now we have aluminum sulfate. Correct formula. Okay. name, formula, formula, name.
Professor, I had a question.
Sure.
The things that we just did, what is that called exactly? For instance, if this was on a test question, it would be what? Take the name of these two elements and create the formula, or is there a different word for it?
Yeah, I'd say, what's the formula for aluminum sulfate? Or what's the name for Al2 parentheses SO4 3? That's exactly how I word it. In fact, I'm doing your test 3 right now. I finished half of it just before I got online with you guys. Okay, barium phosphate. Let's write the formula for barium phosphate. Well, barium is a group 2. That means it's a +2. You look at up here. We did before. And phosphate, like we did before, is, so here's phosphate right here, PO4, and that's a -3. Okay, again, these don't equate together, so we have to think about, we have to have multiples of each to end up with a net 0 charge. Okay, and again, we have a 2 and a 3, so we need to think 6. So in this case, we're going to have 3 bariums and 2 phosphates. So that's a +6 and a -6. So barium phosphate looks like that. Okay, now, is this starting to click to you guys?
Yes.
And this is, did I add, trying to think if I gave you extra practice or not on this. If I didn't, I'm going to the extra low structure practice, modeling practice. Okay, I didn't add the extra worksheets for, I'm going to give you extra worksheets on naming. I'll give you probably 2 more worksheets, possibly 3 more, and give you lots of practice on naming. Some people catch on right away. Other people, it takes a little practice. I want to make sure everyone's covered there. Okay, now when we look at we talked about before, some of the transition metals have 2 names. So when we have a situation we have 2 names, we should have in our minds to be able to name both versions, like cobalt 2, cobaltus, cobalt 3, cobaltic. Okay, so this is what that would look like. Cobaltic chloride, what does that look like? Well, cobalt, as we just talked about, is in different forms. So cobalt is either a +2, cobaltus, or cobaltic +3. Okay, so that means it's going to be +3 version. So when we write the formula for cobaltic chloride, it's going to be, so that's +3, and that's -3. Cobalt is chloride. So we're going to need 2 of these to be a net 0. Or if I asked you to name that, what is the name of FeSO4? Well, SO4 is sulfate.
Iron sulfate?
It is iron sulfate, but which iron? There are 2 irons, ferric and ferrous. Which one is it?
Is ferrous too?
Okay, so ferrous is +2, ferric is +3.
I'm gonna guess it's +2, so ferric.
Well, how many
Ferrous.
irons are here?
1.
1. How many sulfates are here?
1.
1. So that means 1 iron has to be equal to 1 sulfate. Well, sulfate's -2. That automatically makes the iron
Ferrous. Ferrous.
ferrous or +2, exactly. So that means that's going to be ferrous sulfate. What would the formula for ferric sulfate look like? Well, ferric is Fe +3, sulfate is -2. So that means we're talking about 2 of these, 3 of these. We want this to be +6, -6. So the name of the game in ionic naming of binary compounds is balance the charge so the net charge is 0. Balance the charge. Now, sometimes on my, I'm going to move this chart down here. Now, sometimes in this chart, there are things that are left off. If they're left off, I'm going to show you what you're going to do. Okay, so for example, what is the formula for beryllium chloride? Okay, so first thing is chloride we know is a -1. And beryllium, let's look over here. There's barium, but no beryllium.
+2.
Okay, so how do you know it's +2?
It's in group 2.
Yeah, exactly. So if it's in the group 2, or the group where everything is +2, it's +2. So barium is +2. Excuse me, magnesium is +2. Strontium is +2. All these are group 2s. So beryllium, which is not named here, is in the same group. So it's also +2. So beryllium chloride is going to be +2. That means the formula for beryllium chloride is BeCl2. Okay, what's that? V6, 3 SO4s. Well, V is vanadium and SO4 is sulfate. Sulfate, as we know, is -2. Vanadium is all over the place. It's 2, 3, 4. So what does this say right here? 3 minus 2 is -6. And we have 6 vanadiums equaling the -6. So what is each vanadium charge?
+1.
Yes. Because we need +6 to balance the -6. So the name of that is going to be vanadium 1 sulfate. Remember, the Roman numerals indicate charge. Okay, I'm going to do a few more. Before I do a few more here, I want you to notice a few things about. One is we live on the Earth, and our Earth's atmosphere has a ton of oxygen in it. So because of that, a lot of elements are composed of oxygen. Look over here. We have a whole bunch of anions that contain oxygen. In fact, these are called oxoanions. Anions containing oxygen. And they're very subtle. You know, you look at these three. Okay, this is sulfide, sulfite, sulfate. So we're talking about these polyatomics, more than one anions. The naming you need to be very, very careful of, because the difference between these is the number of oxygens. Whether it be no oxygens, 3, 4, we can combine hydrogen with it, so we can have hydrogen sulfate, lots of combinations. So just be very careful when you're looking at these anions, because they differ subtly. Okay. Acetate. Acetate comes from acetic acid. It's the salt of the acetic acid. Acetate can be written a couple different ways. One is a structural version. And the other is a molecular version. The structural version is much more informative of the structure of the molecule than the molecular formula. Molecular formula just says how many carbons, hydrogens, and oxygens we got. It doesn't say how they're put together. So when you're drawing Lewis structures, you don't really know where it's going. If you're drawing a Lewis structure of the structural one, you would know that the oxygens are attached to the carbon, and these 3 hydrogens are attached to that carbon. But bottom line, they're both the -1 anion. They're both called acetate. Similarly here, Okay. Structural one, we know that the oxygens are attached to the carbon. That's what the Lewis structure would look like for that. The Lewis structure for this look like that. So the reason I brought that up is you'll see either version of it. Probably the most common one is going to be this, but you could easily see the other one as well. It's going to be kind of a 60-40. Okay, that's basically it for chapter 5. Excuse me. This cough of mine is kind of getting in the way for this. So are you guys feeling more comfortable on this ionic stuff?
Yes.
Okay, all I can say is if it feels cumbersome for you, you need to do 40 or 50 more of these problems. And it'll click. It's just like the pluses got to equal the minuses. That's all there is to it. And if it doesn't, you got to fuss with the numbers so they're equal. And the numbers you fuss with are the subscripts only. Okay, so I'm going to end this here. I'm going to go ahead and load up some more worksheets for you on naming. The worksheets will be on covalent naming and ionic naming. And actually, I think there are 3 worksheets I'll give you. And one is a combination of the 2. Okay? All right.